All right, so y'all, like I said, this is 9.6, solving exponential. And logarithmic equations. Right, let a few people in real quick. Maybe move the camera up a little. All right, y'all. So first, we're going to start with solving the exponential equations. Now remember, exponential equations come in this form where we got y equals a to the x. So remember, my variable is the exponent in these type equations. So y'all, the very first thing I look at on these equations, I look and see if it's possible to rewrite each side of my equation using the same base. So if possible, rewrite each side of the equation using the same base. Y'all, because what happens if I can rewrite each side of the equation using the same base, then I can come in and invoke what we call the base exponent property. So y'all, this base exponent property tells me if I got two sides, such as a to the x equal a to the y. If I got two sides with the same base raised to an exponent, and these sides are equal, then that means that the x has to equal y. So same bases and two sides are equal, then that means these exponents have to be equal. So that's what we'll do if we can rewrite them using that same base there. All right, let me let one in real quick. Now, if I cannot rewrite each side using the same base, so if it's not possible to rewrite each side using the same base, then I need to take the next few steps I'm going to show you. So if I cannot rewrite them using the same base, the first thing I'll do, because I'm going to have to bring these exponents down. So the first thing I do in order to help me take these exponents and bring them down is I'm going to take a log or an ln of both sides. So remember, when I take a ln of a result to an exponent, I can then invoke the power rule. So using the power rule, bring the exponents down. And rewrite as a product. Ooh, it looks like my hand froze there for a second. So bring the exponents down and rewrite as a product. All right, y'all, then what I do next, I'm going to start solving for the variable. So I'm going to solve for the variable. And y'all, at that point, the last thing I'm going to do, check my answers if needed. All right, so check answers if needed. So remember, this is my exponential equations. Once we go through these, then we'll play with our logarithmic, okay? All right, y'all, so here we go. We're going to start solving equations. So these will actually say solve for x. All right, so let's play with this first one, y'all. I got 6 to the x equals 36. So my first thing I want to do, I'm going to look at this and see if I can rewrite each side of these using the same base. So notice on the left side, my base is a 6. So my question to y'all, can I rewrite 36 as a 6 to an exponent?
Yes, I think yes. Would it be 6 squared?
All right, let me ask y'all this. How many times can you multiply 6 to get 36? Oh, hang on, y'all. My speaker's off. No wonder I'm not hearing y'all. Hang on.
Would it be 6 squared?
Okay, I'm hearing y'all now. Okay, I didn't know my speaker was off, so I've probably been getting questions out of y'all I don't even know about. Okay, my bad. So now I'm hearing y'all. So yeah, we can write 36 as a 6 squared. So we bring down our 6x. That's going to equal 6 squared. So right here, we can invoke that base exponent property that tells me if the bases on each side match, that means these exponents got to be equal. So y'all, at this point, my bases match. And since my bases match, we know that x equals 2. And y'all, if y'all wanted to check that, put a 2 in for that original x. 6 squared equals 36. That is definitely true. So we know we got the right answer. So y'all, these aren't too bad if you can actually rewrite them bases, okay? So look at this next one. I got 4 to the 5x equals 16. All right, so I got a base 4. Can I rewrite 16 using that base 4?
Yes.
Okay, you're going to make that what?
4 squared?
There you go. So we're going to rewrite 16 as 4 squared. So y'all bring down your 4 to the 5x. That's going to equal 4 squared. All right, so here we go. The bases match. So we know our bases match. So that means these exponents got to be equal. So our 5x has to equal 2. All right, so this one we actually do got to solve for this x. So I got one step and we'll be done. And y'all, here we go. We're going to divide both sides by that 5. So these 5's cancel, giving me 1x. Can't do nothing over here, so x will equal 2/5. So what happens if you plug that 2/5 in for this x, the 5's cancel, and you got 4 squared, and guess what? 4 squared is 16. All right, y'all. So do y'all have questions on those? So the trick on those when we start out is if we can rewrite them, we really want to do it that way, okay? All right, y'all. So here we go for our next problem. How about 5x equals 24? Can you rewrite 24 with a base 5 raised to an exponent?
No.
No, so y'all, we cannot rewrite this one. So remember on my steps, if we could not rewrite them, what we got to do is we got to take a log of both sides. So I'm going to take a log of both sides. So I'm going to have a log of 5 to the x equals a log of 24. Now, y'all, I know we just learned this last class, but what we need to do now is invoke what we call the power rule. And it has to do with these exponents. What do we need to do with that exponent? Remember, it was usually the last step I did, but remember this x has to come down to the front. This is where we're going to rewrite it as a product. So bring the x down and you'll get an x log 5 equals a log 24. So y'all remember, if you got a log with a result to an exponent, we're always going to bring them exponents down to the front. So y'all watch this. I got an x times log 5 equals log 24. So I'm going to come in and divide both sides by the log 5. That's going to equal my log 24 divided by my log 5. So y'all, the logs cancel out over here. We got our x. Now, since these are logs, we're going to get decimal answers. And when we get decimal answers, we're going to round them off 4 decimal places. Now, y'all, another trick on this, you gotta close these parentheses on your numbers when you do your logs. So what I got, log 24 over log 5. I'll go to the calculator and show you how I would do that. All right, so I'll hit my log. And I had what, 24, close parentheses, and then divide by my log of 5. All right, also remember, around 4 decimal places, I got what, a 1.97. Looks like that's going to stay 46 because after the 6 is a 3. So that's going to stay 46. So that's the trick, but with the ones where you gotta rewrite them like this and use the logs, those answers will have decimals, okay? All right, y'all, I've shown you both ways, so let's see what we can do here. We got 3 to the 9x minus 5. That's going to equal 81. So y'all, can you rewrite 81 using a base 3?
Yes.
Definitely. Because remember, 9 times 9 is 81. And each of them 9s is 2 3s. So that gives me what, a total of 4 3s. So y'all, we can do that as 3 to the 4th, okay? All right, so here we go. Bring down the 3 to the 9x minus 5 is going to equal 3 to the 4th. Then y'all were happy these bases now match. So since my bases match, these exponents got to be equal. So 9x minus 5 has to equal that exponent, which is a 4. All right, y'all know what we got to do now is solve for the x. So what? Add 5 to both sides. Nine x is going to equal 9. And then let's divide by the 9 and be done. So y'all, x is going to be 1 for that. So if you put a 1 here, 9 times 1 is 9. 9 minus 5 is 4. And we know that 3 to the 4th power equals 81. All right, y'all with me? Any questions yet? So how about that, y'all? I got 3 to the x equals 5. I don't think it's going to be possible to rewrite a 5 using a 3 on this, right? So remember, since we cannot rewrite this using the same base, so I cannot rewrite, we're going to jump right into taking a log of both sides of this. So you can't rewrite it, take a log. So we'll have a log of 3 to the x equals a log of that 5. So y'all think about this. What would I do next to that?
Move that x to the front of the log.
Yeah, definitely. We're going to move that front x up there. Good job. So that we get a x log 3 equals a log 5. And here we go, y'all. Remember, log 3 is a number. So now you're just going to divide both sides by that log 3. All right, so once again, my logs cancel. And just remember, close those parentheses on those numbers. So y'all, let me see. When I did that one, I ended up getting a 1.4650 rounded off. All right, y'all. Now I'm not going to lie. This number 6 is a little crazy here. But usually the answer I get on number 6 will be the same answer y'all are going to get on number 6. They're just going to throw the numbers off a little bit. But here we go. I got 10 to the negative x equals 8 to the 5x. Y'all, there's no way I'm going to turn a 10 and an 8 into anything with the same base on them. So this one cannot be rewritten for sure. So I'm going to jump right off and take a log of both sides of this. So we're going to have our log 10 to the negative x is going to equal the log of 8 to the 5x. All right, y'all. Guess what? On both sides, we're going to bring our exponents down. Well, let me show you another trick on this one. Yeah, first let's bring our exponents down, and then I'll show you what I do to that. So that's the whole reason we took the log, was to bring those exponents down so that I get a negative x log 10 equals a 5x log 8. So y'all, where this one gets sort of tricky is because I got these x's on both sides here. And to solve that for the x, I need all my x's on one side. So the first move we're going to do here, we're going to add x log 10 to both sides so that we can move this over. So look at this. On the left side is now a big 0. These are not like terms, so I'm just going to go 5x log 8 plus my x log 10. So notice, all I've done so far, I've got my x's on the same side. So y'all, the $1 million question of the day at the moment. I got an x in two terms that are not like. How can we turn these two x's into one x? And y'all, I want y'all to
Combine
think.
like terms.
Well, they're not like at the moment. We can't add them because remember, I got a log 8 here and then a log 10 here. But what I want y'all to think about is a type of factoring that you can do to this. So, Jonathan, let me ask you this. You got this term and this term, right? What do they have in common?
Yeah, I don't know. It's a tricky one.
Well, they both got an X in them, don't they?
Yeah.
So what I want y'all to do on this kind of situation is factor that X out as a greatest common factor. Since it's common to both terms, we can factor that X out. And remember, everything else could go into parentheses. My 5 log 8 plus my log 10. So y'all remember, when you got a variable in two terms and you need to turn it into one, pull it out as the greatest common factor. So now I got 0 equals x times my 5 log 8 plus log 10. I'm going to now divide both sides by 5 log 8 plus log 10. Because y'all watch what happens. That right side, that now cancels. So I'm going to get my x. And guess what? I don't care what's on the bottom of this. You got a 0 on top. And 0 divided by anything is a big 0. And that makes sense on this. If you put a 0 here, 10 to the 0, remember that equals 1. If you put a 0 here, 5 times 0 will make that 0, and 8 to the 0 power equals 1. So y'all, that was a little tricky, but I'm pretty sure y'all are going to get the same answer as I think all they do is change the numbers on it, okay? So be careful on that. All right, y'all, moving on. What's next? Number 7. I'm going to flip my paper over. How about this? E to the T equals 153. That sort of makes you want to say phone home, don't it? All right, y'all. I'm not even going to try to rewrite each side using the E as the base. So I cannot rewrite. Now I'm going to do something different to this one. I'm going to take a log of both sides, but I'm going to use a special logarithm since I got this E here. So when I got an E as my base, I'm actually going to take the ln of both sides. So let's take the ln of both sides. We got the ln of E to the T equals the ln of 153. Now, y'all, at this point, I'm going to alert y'all to something. Remember, this ln is really, so this ln of E to the T, that's really a log base E of E to the T. What happens here, if you pull that T down to the front, you get T times log base E of E. So my question to y'all, what does this log base E of E equal in the long run?
I might be wrong, but is it 1?
It's a 1. So when you got that T down here times 1, that ends up being just the T. So when you take the ln of E to any exponent in the long run, it's just going to equal that exponent. So good job. Who was that, Destiny?
Yes, it was me.
Okay, good job. So all that's left over here will be our T equals the ln of 153. We can now just punch that in our calculator. And rounding that to 4 places, I ended up with a 5.0304. So I've got another one using the E. So let's play with this one. E to the negative 0.87 T is going to equal 0.89. Woo, and I'm not trying to rewrite them using the same base. So I'm going to jump into taking my logs. And remember, I'm going to take an ln of both sides since I got an E. So y'all, I got ln E to the negative 0.87 T is going to equal the ln of 0.89. So the question of the day, doing all this, what's the left side going to give me?
T.
Oh, just a little bit more. Because notice my whole exponent is this negative 0.87 T. So remember, all that would come down to the front. So you're really close, but we need that negative 0.87 T. And that's just going to equal what? That ln of 0.89. Yeah, so just remember that whole exponent will come down when you do that, okay?
Okay.
All right, y'all. I need to make that a 1T, so I can now divide both sides by the negative 0.87. All right, just remember on the right side, we're going to have to close that ln when you put it in as the 0.89, okay? Close parentheses, then divide. So y'all, let me see, that cancels over here. So all I have is my T So y'all, when I punched that in, I ended up getting a small number. It was a 0.1339.
I got a question.
Yeah, I hear you.
That negative 0.87, do that not turn into a positive? Like when you add to both sides?
Well, remember, I'm not adding it, I'm dividing by it.
Okay, so
Because remember, since that negative 0.87t is being multiplied, we have to undo that multiplying by dividing them, okay?
okay.
All right, y'all, here we go. 6 to the x.
Before we start number 9, I have one quick question.
Yeah, I hear
Okay,
you.
so on number 8, I have a question. Why didn't we include the e into the first equal?
Right here?
Yes.
Okay, so what happened on that?
Mm-hmm.
I'm gonna write that right here. I had an ln of e to negative 0.87.
Mm-hmm.
So remember, my first move is to bring that down to the front.
Right.
So I'll get a negative 0.87 ln of e.
Mm-hmm.
But remember, what's the ln of e equal?
I think.
Because remember, ln of e is like this log base e of e.
Oh, it equals just 1.
1. So
Yeah.
so that turns into a 1, and all that's left is that negative 0.87. So here's the thing. Anytime you take an ln of an e, that answer is only going to be whatever that exponent was, okay?
Okay, I'm sorry, I missed that part. Thank you.
Oh, that's good, no problem. That's how y'all learn, by asking, right? All right, y'all look at this. 6 to the x equals 3 to the x plus 1. So this is another one I didn't really care for, but it's in the homework, so we're doing it. I'm not even going to try. I cannot rewrite these, so I cannot rewrite again. Now, since these aren't e's, I'm just going to take a log of both sides. So the only time I'm really using the ln is when I got the e. Although all of these you can use the ln or the log on them, okay? So here I'm just going to take the log of both sides. So we got a log of 6 to the x equals a log of 3 to the x plus 1. So my next move is to bring these exponents down. Now remember, we got to bring this whole x plus 1 up to the front. So this side will give me an x times a log 6. But y'all, here's the trick. Oh, let me let one back in. Here's the trick on this one. Since you got 2 parts to your exponent, you got to put the x plus 1 in parentheses times that log 3. Because remember, both of these are affected by this, okay? So yeah, on number 9, you'll have to put those in parentheses. So here's your next step. Can't do nothing on this left side. The right side, I need to get rid of the parentheses. So both of these, we're going to multiply times that log 3. So I'm going to bring down the x log 6. Because remember, that's the only way I can get rid of these parentheses, by actually distributing and multiplying. So the x times log 3 gets you an x log 3. And then 1 times log 3 is just a plus 1 log 3. All right, so really all that just by taking the log got me to this point. Now, we need to solve for this x, but remember, I got x's on both sides. So this x over here, I want to bring it to the other side. And to do that, we're going to subtract. So subtract x log 3 from both sides. So over here, I get my x log 6 minus my x log 3. So that canceled on the right side. All that's left over here is a log 3. So I'm going to ask y'all again. I got an x in both of these terms. How can I turn one x? How can I turn these two x's into one x?
Take the X out. I can't think of the word.
Combine.
Is it factor out the X?
I'm going to factor out the x. Good job. So we'll factor out an x. In parentheses, I got a log 6 minus a log 3, all equal to my log 3. All right, y'all, x times these parentheses equals log 3. So to get my x to be a 1x, I'm going to divide both sides by these parentheses. So that'll equal my log 3 divided by log 6 minus log 3. So look, this cancels. All that's left over here is your x. Now, y'all, here's the thing. You can do this problem two ways, and I'm going to show you how I would put in this log 3 over log 6 minus log 3. So I'm going to jump us to the calculator real quick. So y'all, the first thing you can do, if you hit alpha, the green button, and then the y equals, number 1 is numerator denominator. So hit enter on that and bring the fraction up. Then you can punch it in like it looks. Log 3 on the top. So log 3, close parentheses. And then arrow down to the bottom. We have log 6. So log 6, close parentheses, minus log 3, close parentheses. So if you use the green button, alpha, y equals, you can bring it up looking like a fraction, just like it looks, and then hit enter. And I get 1.58. Oh, look, that 49 has a 6 after it. So that's going to round that up, which rounds to 4 up. So 49.6 will round up to a 50. So we get 1.5850. Now, say you don't have that alpha y equals. For some reason, you forget about it. So let me show you how you would have to do this. You would do your log 3, close parentheses, and then hit divide. Now, since the bottom of my fraction has 2 parts, I have to put the bottom in an extra set of parentheses. So open parentheses, then do your log 6, close this parentheses, minus your log 3, close parentheses, and then close the main parentheses for the bottom. So the bottom has to have an extra set on it. But look, when you hit enter, you get the same thing, 1.58496, okay? So yeah, I sort of like using that alpha y equals. So remember, alpha y equals, that gets me the n over d, which is for my fractions, okay? All righty, so now we're going to move on and do the logarithmic equations. So I'm going to give you the steps I use on logarithmic. So here we go, solving logarithmic equations. All right, first thing you want to do, if possible, we want to combine logs on each side. So combine logs on each side if needed. So you might not have to do this every time, but if I got two logs on one side of that equals, I'm going to combine them, and that means I'm going to write them as a single logarithm. So that's the stuff we did the other day when we looking at our properties of logs. We turned 2 into 1, okay? If they were being added, we wrote them as a product, remember? If they were being subtracted, we wrote them as a quotient. All righty, at this point, do we have a log base equal to a log base? So if I got a log base 5 on one side equal to a log base 5 of something on the other side, I can invoke what we call the logarithmic equality. And this is sort of similar to that base exponent property. This one tells me log base A m equals log base A n. If two sides are equal and they have the same log base, both of these have an A, then y'all, that means this result has to equal that result. So that means then m equals n. Okay, so we want that to happen. If not, so if we don't have that, so if not, then what we do, we're going to rewrite as exponential. So that's why we was having y'all do them, we're converting them from logs to exponential, and then you had to convert exponential into logs. And that was in the last section. All right, once I rewrite it as exponential, I'm going to solve for that variable. Then I'm going to check if needed. Now I'm going to say this. You better check these answers on some of these, because let me ask you all this. Just on the side here. What happens on this problem if I take the log of a -4? So that's what we did last Wednesday. Y'all remember what we said if we tried to take the log of a negative number?
Wouldn't it? I may be wrong, but is it a 0 or something like that?
I think you're on the right track.
Was it a fraction?
You didn't get any answers out of this as far as numbers.
Won't work. It won't.
It won't work. Remember, these are the ones that you got the error messages on. And it says not real answers and all that fun stuff. So remember, you can't take the log of a negative number because it does not exist. So if I get any negative answers on here, I'm throwing them away because I cannot take the log of a negative number, okay? So here we go. Cannot take logs of negative numbers. Because remember, those were the ones that does not exist. So I will say on some of these, you will see one positive answer, one negative answer. You got to throw away that negative one and only keep your positive answers, okay? All right, so guess what? These are going to say solve for X. And these start about number 10. So y'all going to start off with this. Log base 4 of X equals 2. So notice, I don't have but one log on one side, so there's no way I can combine any logs on either side. So there's no way I'll have a log base equal to a log base because I don't have a log on the right side. So since I don't have any of that going, I'm down to this step which says rewrite as exponential. So I'm going to rewrite this one as exponential. Remember, 4 is your base. So bring down that 4. The exponent is the 2. Remember, the logs find exponents, so you got to get used to that exponent being that right side here. And then 4 squared equals that result of an X. All right, y'all. So I'm bringing down that X. Tell me that answer and we're done.
16.
16. So log base 4 of 16. So 4 to the second power would definitely give me my 16. Okay, so that's what we mean when we talk about rewriting them as exponential here. Base, exponent, result. All right, y'all, log of X equals -5. So I'm going to rewrite this one as exponential because I only got the one log on one side. But y'all, I need to figure out what's the base.
Is it 10?
It is definitely a 10. So I got my 10 to the -5 equals X. So let me see, when you punch this on your calculator, you should get a 0.00001 equal to your X. All righty, let me try this one, y'all. How about this? Log base 6 of 4x minus 4 equals 4. So just like these, you got one log. So the only thing you can do is rewrite this as exponential. So y'all, we got a base of 6 here. We got an exponent of 4. So 6 to the 4th is going to equal that result, which was a 4x minus 4. All right, y'all. So we need to figure out what 6 times 6 times 6 times 6 is. So, ooh, that's a lot of 6s. I think when I punched that in, I ended up with 1,296 equal to my 4x minus 4. So it's pretty close to these, but I got a little more work to get to my X here. So let's see, to get that X, we're going to add 4 to both sides. So that's going to give me 1,300 over here equal to my 4x. And I'm going to pull that down for a second. And then what? Divide both sides by 4. On the right side, I got my X now. So let's see, 1,300 divided by 4. Let's see, when I push that in, I had 325. Okay, so that's what you got to watch for on these. Once you got them rewritten, just start solving for your x's, okay? All right, y'all got a question yet? And y'all, I'll tell you, they're not too bad. Just follow your steps, okay? Now let's up to Annie. Let's do some of these where it wants me to combine logs. So how about a log x plus a log x minus 21 is going to equal 2. So do you see over here, I got 2 logs over here. I want to combine these and rewrite as a single log. So we want to rewrite as a single logarithm. So remember, I bring out the log. So y'all, my question to y'all is this. When we did this in the last class, if they were being added, did I rewrite them as a product or did I rewrite them as a quotient like division?
Wasn't it product?
It was definitely a product. So we'll have our x times x minus 21, all that equal to 2. But notice, we now have a single log over here. And up here, once we got it as a single log, we still don't have a log base equal to each other on both sides. So now we're going to this step. We're going to rewrite as exponential. Oh, so you don't have a base. So once again, that base is a 10. Then you got a 2 for your exponent. And that's going to equal that result, which is an x times x minus 21. All right, y'all. So let's figure out 10 squared. Is going to give us 100. Now, we got to get rid of these parentheses over here. So guess what? We're going to distribute the x and get rid of these parentheses. So x times x gave us the x squared. X times negative 21 gave me a negative 21x. Look at this. This one's quadratic. I got an x squared term in it. So I need everything on one side equal to a 0. So to get a 0 over here, we're going to subtract our 100. So y'all look here. You got a 0 equal to x squared minus 21x minus that 100. At this point, you can do the quad if you want to, quadratic formula. But y'all, I sort of like factoring these. So I'm just going to factor it. I got an x squared. That's an x and an x. That last sign's negative, so you got a plus and a minus. So y'all, the trick here, I need factors of 100 that'll subtract and give me 21. So y'all, how about 25 and 4? That'll work, right? So remember, 25 is my larger number. It's going to be negative. And then 4 would be your positive. All right, but y'all, if you don't like factoring, at this point, hit it with your quad formula. 1, negative 21, and negative 100. It'll give you the same 2 answers I'm about to get, okay? So now I set both my factors equal to 0. And I solve them. So y'all, the first one, we're going to subtract 4. I get x is negative 4. The second one, I'm going to add 25. And I get x equals 25. So y'all, what's our final answer?
$25.
25. Good job. We cannot take this negative answer, y'all. Scratch it off. So right here, can take negative answers. All right, good job. The only answer would be that positive 25. All right, y'all. So let's see what's next. Let me fix my paper again. All right, so number 14, let me get a camera back up. All right, so 14, I got a log base 3, t plus 16 minus a log base 3, t plus 7 is going to equal a log base 3 of a t. Guess what? Over here, you got more than one log. So we need to write as a single log. Whoops, let me let one back in real quick. So if I rewrite this one as a single log, they're being subtracted. So remember, if they're being subtracted, they're going to look like a quotient. The positive stuff goes to the top, and the stuff being subtracted goes to the bottom. So we're going to pull out that log base 3. T plus 16 will be on the top over t plus 7. And that's going to equal my log base 3 of t. But do y'all see what I got? I got a log base 3 on the left side equal to a log base 3 on the right side. So my log bases are equal. So when my log bases are equal, that means this result equals this result. So a t plus 16 over t plus 7 will equal that t. Okay, so just remember, if you can get them to be equal like these log 3s, then the results are equal. Now, y'all, I'm going to show you how I would solve this. I would put a 1 under that t, and I would cross multiply this. Cross multiply, take the top times the other one's bottom. So t plus 16 times 1 is t plus 16. Now, the t plus 7 multiplies by the t. But remember, both of these are going to multiply by the t. So I got a t times a t gives me a t squared plus my 7 times the t is a 7t. So that's the easiest way on these is just cross multiply, get rid of the fractions. We got a t squared term, so everything needs to be on one side equal to a 0 here. So you ought to get a 0 here. I'm going to subtract t and subtract 16 from both sides. So the t plus 16, the negative t, negative 16, all this, that's going to give us a big 0. So let's see what we got over here. T squared. 7 minus 1 give me 6t minus the 16. So y'all know what time it is. It is time to factor. And I will say this, on all the ones that got to be factored, they will be negative at the end, so you will have unlike signs. You'll have a t plus and a t minus. All right, y'all, factors of 16 that subtract and give me 6.
Eight.
82.
All right, 8 and 2. Let's see. 8's bigger, so it's positive at the moment, and 2's negative. Or you could have did the quad, okay? So now let's set both these equal to 0. And we'll solve them. So subtract 8 from our first one. What? Add 2 here. All right, y'all. Final answer.
2.
There you go. So once again, we're kicking out that negative answer, okay? These aren't too bad. I think they're better than doing some of the equations we done earlier in the year. All right, y'all. Log base 4, x plus 1 minus log base 4 of x equals 3. So look on the left side. Guess what? We're going to write the left side as a single log. Once again, they're being subtracted just like this one, so it's going to look like a quotient again. So bring out that log 4. The positive stuff will be on top. That's the x plus 1. This stuff being subtracted goes to the bottom. That's the x. And all that is going to equal my 3. Now, here's the difference on this one and this one here. On this one, I had a log base 3 on both sides. I've only got a log on one side. So y'all, for this one, we're going to have to rewrite this one as exponential. So your base is a 4. Exponent is a 3. And 4 to the third has got to equal to x plus 1 over x. All right, y'all, let's see what we get here. 4 times 4 is 16. 16 times 4, that's going to give us 64 equals x plus 1 over x. But now I still got a fraction like this times another side. So I'm just going to throw a 1 under that 6, and I'm going to cross multiply. Y'all watch this. 64 times x gives me 64x. X plus 1 times 1 is just going to be x plus 1. So notice how they start out similar, but because this side didn't have the log, I had to rewrite the exponential stuff, okay? All right, y'all, let's see. We want the x's on one side, so let's subtract the x from both sides. So 64 minus x is what? 63x equals that 1. And y'all, our last step, divide both sides by 63. So there we go. That cancels again. And you will get an x equals 1 over 63.
Could you just simplify that into 63?
If it was the other way, I could have. If I'd
Okay.
had something like this, 63 over 1, then I could have. But remember, if you got a 1 on top, you definitely got to keep that 1, okay?
Okay.
All right, y'all. So 2 more to go. All right. But they're going to throw all kinds of logs at us. Watch this. I got a log base 3 of x plus a log base 3 x minus 1 equals a log base 3 of 6. 2 logs on the left side So once again, we're going to rewrite this as a single log. Once again, they're being added. So remember, when they're being added, we're going to rewrite them as a
Product.
product. There you go. So that's going to give me what? X times the X minus 1. Oh, that's going to equal what? Log base 3 of a 6. Well, guess what? Y'all notice my log bases match. So since these log bases match, we know that this X times X minus 1 has to equal that 6. So I really love it when you can get these things matched. So now here, remember, we're going to get rid of parentheses by distributing our X. So X times X is X squared. X times -1 is a negative X. All equal to 6. So y'all look here. X squared again, so we want a 0 over here. So we're going to subtract 6 from both sides. So y'all get an X squared minus X minus 6 equals 0. So notice we're now at the part where we can factor. Once again, you get an X plus, X minus. So for this one, I want factors of 6 that subtract and give me 1.
Even
Oh, I heard something, but I didn't hear it.
2 and
Okay, 2 and 3, good job. Let's see, the 3 will be negative and 2 positive. All right, set both them equal to 0. So y'all, the first one, we're going to subtract 2. X equals -2. Second one, I'll add 3 and get X equals 3. So final answer.
3.
All right, so I want to kick out that -1 again. I'm gonna let y'all catch up and then I'm gonna flip over because this next one's sort of long. All righty, so y'all ready? Let me get that next one done. All right, y'all, here we go. 17 log base 3 X plus 12 plus log 3 X minus 12 is going to equal 4. So y'all, what's my first move?
single.
There you go. We're gonna make that a single log. So is it going to be a product or a quotient?
Product.
So I got my X plus 12 times my X minus 12. And let's see, all that's going to equal 4. Well, y'all, sadly, I don't have a log on the right side, so I can't use my log base. But at this point, we could rewrite this one as exponential. So our base is a 3. My exponent is that 4. And that's going to equal this X plus 12 times this X minus 12. All right, so I'm gonna Well, what's 3 to the 4th? We knew that from a while ago. 3 times 3 times 3 times 3. Gave us
81.
81. Now, y'all do realize that these are conjugate pairs, right? X plus 12, X minus 12. Since these are conjugate pairs, I'm going to shortcut FOIL these. Remember, the shortcut FOIL, I can do the X times X, which is an X squared. And then I can do the 12 times negative 12 is a negative what, 144? So remember, you can always shortcut the conjugates, because what happens, this 12x on the inside and the negative 12x on the outside, they're always going to cancel, okay? But y'all, I want to show you something on this one. I don't have the X term on this one. All I got is the X squared term. So to me, the easiest way to solve when you just got an X squared term is to get the X squared by itself and do your square root stuff to it. So to get this X squared by itself, I'm going to add 144. So notice, all I got on that right side is my X squared. And let's see, 81 and 144 gave me 225. All right, I'm going to take square roots of both sides. So I know that's going to give me my X, and this is going to give me a plus or minus something. So square root of 225.
Ain't it plus or minus 15?
There you go, plus or minus 15. So y'all, that means my two answers are X equals a 15, X equals a negative 15. Which once again means my final answer is
15.
15. Good job. So y'all, that's the trick on these. Just go through these little steps we had over here. Remember, first thing you're going to try to do is rewrite them if you can. Sometimes you'll get a you can use the base exponent property and then go through those steps. And when we hit these logs, we just went through the steps. Could we combine logs on either side? And once we got through that step, we looked and seen if we had a log base equal to a log base. If we did, we just set the results equal to each other. If not, then we rewrote them as exponential. Solve for the variable and then check them answers. So y'all's is going to go right along the same steps on those, okay? All right, y'all. So let me knock this share down.